Welcome to Module 204A. So far, we've looked at the four different types of diagrams that we have, and we looked at the symbologies that we can use within those different types of drawings as well. The next thing we're going to do is get some practice on how to read the diagrams to understand what the order of operations inside them are. In order to understand our drawings, we need to be able to understand the different components that they're broken down into. On the circuit that we see on the screen, we actually have three different components that we need to be able to recognize. Firstly, we have our control circuit, which is going to contain the majority of all our control components, such as our stop and start switches, our holding contacts, our coils, our overloads would all be found inside the control circuit. If I had any pilot lights or warning lights or anything else, that would also likely be found inside the control circuit. Beyond the control circuit, I have what's called the control transformer, which is supplying the power for my control circuit through a transformer fed from the power circuit itself. On the power circuit, I can see my 3-pole disconnect. Right below that is I have 3 inline fuses, and I can follow that over to the right-hand side through a set of contacts labeled M. Those set of contacts are being controlled by the coil M inside my control circuit, and they are going to be able to control the power that goes to the motor. Right after the contacts M, I see an overload heater, which leads into the motor after that. All those different components are part of the power circuit. So that is normally on a motor control circuit, that would be my high voltage circuit, where my control circuit would be my low voltage circuit. We also need to be able to recognize the fact that we have special contacts within our circuit that we need to be aware of their function. The first one is my holding contact, which is a normally open contact that's always parallel to my start button. The job of this contact is to be able to hold the circuit in an energized state after I release the start button. This gives me the advantage that if I ever have a power outage, it's automatically going to de-energize the circuit and not allow it to restart automatically, which is much safer, especially when we're dealing with large, dangerous equipment. But the holding contact is there just to make sure that that motor control circuit can continue to operate safely and we don't have any interruption to it. The next type of contact we need to be aware of is, of course, the overload contacts. And as I mentioned before, they're typically found between the motor controller and line 2. However, on some drawings, we will find them at the very beginning of the line. So they will be found between line 1 and our stop button. So be aware of the different types of drawings that we have, and we will discuss the different types a little bit later on in the course. But we should be able to recognize my normally closed contacts are my overload contacts, and those are being controlled by my overload heaters that are part of my motor controller. We also need to be able to recognize different types of interlocking, and this is especially important when we get into reversing motor controllers, where we are going to want to incorporate a number of different types of interlocks. The first type of interlock is called a mechanical interlock, whereas there's an actual physical blockage between two armatures that will not allow both of them to be pushed down at the same time. Remember, when we push down the armature, we're actually closing a set of contacts inside that coil. So if there's going to be a dangerous situation, such as with the reversing motor starter, where if I hit both of those at the exact same time, I could create a line-to-line short, I want to have a way to prevent that. And we can do that mechanically using the mechanical interlock. The second type of interlocking I can have is push-button interlocking. And since my push buttons can have all sorts of different types of contacts clipped to the back of them in order to change their orientation, it's easy for us to build a push-button interlocking system. What's important for us to understand is how to recognize that on a drawing, and I will see the hatch lines go between the different buttons that are associated. For example, if I were to hit the stop button in the first line, since that is connected to the start button in the second line, this is my interlocking, whereas when I activate one button, both of those move at the same time. So my stop button in my forward circuit will also activate the start button in my reverse circuit at the exact same time. Thirdly, I have electrical interlocking, in which I'll have normally closed contacts that are in each other's line. So we can see in my forward starting line, I have a normally closed contact that is labeled with an R. That means that the R coil is operating that. With this type of system, if my F coil is energized, that means in the reverse circuit, that F contact, which is normally closed, will be open. So there's no possible way for me to feed energy to my R coil. So I can't even try to start that. So my electrical interlocking puts a blockage in the form of a normally closed contact in the path of another coil in order to prevent them both starting at the same time. Let's look at this schematic diagram to follow the order of operations that we can see in here. First thing we have to do is do some device identification. First thing I'm going to look for is I'm going to look for my power supply. Here I have a 120 to 24 volt transformer. The 120 volt is coming from a line 1 to line 2, and I can also see that 120 volt is associated with the very bottom rung between the R3 normally closed contact, the K3 switch, and the bell. So that bell is a 120 volt bell. Beyond that, I have my 24 volt control circuit that's being fed from the secondary side of that transformer. That includes all my other alarm switches, as well as my relay, as well as a 24 volt bell on the inside of the building. The next thing I can recognize is the fact that I have a holding contact in parallel with switch K. This holding contact is being controlled by coil R. So when coil R is energized, then that holding contact is going to energize as well. After I've identified those parts, I need to make sure I check the rest of the drawing to see if there's anything else on this drawing that I don't recognize. Now everything in here is a standard symbol, so I can see my normally open and my normally closed switches, and I can see my bells, and I can see my contacts. One thing I do see though is my normally open switches are all labeled with Ks, K1, K2, and K3. If I check the legend, that will tell me that those are all keyed switches, so now I know what the operation and the function of those switches are, and I know how they're going to be used. Make sure if you do see any symbols that you are not aware of or you don't understand the labeling on the drawing, check with the legend, and the legend should help you out. The next thing I want to do is I want to analyze this circuit to see if there's anything that's going to happen as soon as I energize it without pressing anything. And the one thing I do see here is I have this line here. There is no disconnect between my 24 volt line and my R2 normally closed contact and my inside bell returning back to my 24 volt transformer again. That means that's a complete loop. So as soon as I energize the system, I should expect that inside bell to be ringing automatically. Keep in mind that my R coil here is controlling all three of these different contacts. So it controls the holding contact, it controls R2 contact, and it controls R3 contact. So as soon as I energize the system, that inside bell is going to ring, and in order to stop it from ringing, I need to hit the K switch. And that's a normally open momentary contact switch, and that will allow R to energize and will stop the inside bell from ringing. So when I analyze this circuit, I turn it on, I hear the inside bell ring, I hit the K button, the momentary push button, it energizes R, which closes my holding contact, which allows me to release K. Now I have a constant path from my 24 volt transformer through my R1 contact, through all my normally closed alarm switches, going to my relay. That relay is silencing my inside bell, and it's also silencing my outside bell. My outside bell is also being controlled by a key switch, so that outside bell can be silenced by key. So we can put that in there just to make sure that if we are going to do any testing on the system, we can isolate that bell so it's not ringing and disturbing the neighbors. I can also see that I have a key switch for K1 and K2, and each of these are bypass switches. K1 would bypass alarm switch 1, which could be, for instance, the front door. If you don't want the bells to be ringing as soon as you enter the front door, you would activate key switch number 1. And key switch number 2 bypasses all the alarm switches to make sure that if we need to, we can silence the entire system and work on any of the different components that we want to work on. Analyzing the schematic diagrams like this to understand how they are all connected to my power supply, where I'm expecting power to go, and being able to identify which parts are related is a very important skill that we want to make sure you guys master. So take some time to really look over any of the schematic diagrams that you're shown so that you know how to analyze them. Okay, so now we have discussed the 4 basic types of electrical control drawings. We have looked at some of the symbology that we're going to be using on schematic diagrams. In particular interest for us is the motor controls. And we have described the sequence of operation of a control circuit by going through a schematic diagram and looking at some of its more vital parts. You've now reached the end of 204A, so return to Blackboard, complete the self-test, and then continue on to 204B.